Hello guys, welcome to the channel. Today I have a really fun integral with some logs and some trig. So let's just dive straight into it. Cool, so here's the problem, and I actually prepared a hint as well. So I'm just going to pause for a moment for anyone who wants to try the integral without the hint. Cool, so the hint I prepared is to try and write everything in terms of x and 3x. And I mean these like the trig functions, so the sines and causes, to write them as x's and 3x's and try and simplify from there. So I'm just going to pause for a moment for anyone who wants to try with the hint. Cool, let's dive straight into it. So I think the first thing to see, like when we're looking at it, is that we have loads of sines and causes, and we have different multiples of x as well. So this needs some simplifying with some double angle formulae or something like that. And we have it all inside of a log and a square root. And luckily, the log will make the square root quite easy to deal with. Um, but the log might be a bit of a problem. So that's just something to be aware of. But a good starting point is just to try and deal with the simplify the sines and causes. So a good starting point would be to focus on this fraction here and use double angle formulae. So when we have sine 2x is equal to 2 sine x cos x, and that's quite literally here with 2x, and also if we 6x, we can split it into 2 sine 3x cos 3x, just like so. And then these 2's here can cancel. And then the next thing to do is to try and write everything as a fraction with a common denominator. So we have sine squared x and cos squared x as our like lowest common multiple, I suppose. So there you go. So if we multiply everything out, we'll get this. And then we can just write it as one fraction, just so that just so it's a bit cleaner what's going on with what's going on. And then what I did here is I just rearranged it and wrote it with this -2 in the middle here. Um, and that's all that is to try and recognize this pattern here, which is when you have a minus b squared is equal to a squared minus 2ab plus b squared. And actually, if you pay really close attention to detail, we can see that a is equal to cos x sine 3x, and b is equal to sine x cos 3x. And if you expand 2ab's or minus 2ab's actually it holds true with this. So we can actually factor it out just like so using our substitution. And then from here, we can take advantage of log laws with the square root and just take the square root out as a half. There we go. So it already looks a lot more promising, but we still have some more work to do. And actually, there's something really nice to spot here, which is when we have cos sine and sine cos, we can actually there's actually a double angle formulae, a slightly different one. So with sine a plus or minus b. So the first one we used, like all the way back, that's if we have the same thing. So this would be like x plus x, but if it's different, which is a and b, we can actually use a. This is the equation we use, and we can see straight away it applies because um, we have we have a sine a, which is 3x, and cos b, which is x minus a sine b cos a. So we can see that it's going to be that a is a 3x and cos is a is 3x and b is x. So just like so, we get this, and then 3x minus x is just 2x. And this is perfect now because um, we can clearly see things are cleaning up. But we still have the numerator in terms of 2x and the denominator in terms of x. So we can take advantage of a double angle formulae again with sine. And I've just left the box with a little bit of room just so I can rearrange to have half of sine 2x, just like so. And what we can then do is I've just factored out the squared from the sine squared x cos squared x. So we just have sine x cos x all squared, and we can clearly see sine x cos x is half sine 2x, just like so. And then what I did is I factored out the half outside of the brackets. But when you factor it out, you just need to be careful because there's a squared here, so you need to make sure to square half, and a half squared is a quarter, just like so. And we can see that the sine 2x squareds will cancel out, just like so. So it actually really cleans up from here because when we have 1 over 1 over 4, that's the same as just having 4. And then we can take advantage of log laws again, but bring this half back in, just like so. And then we can see that log root 2 of 2 is going to be 2. And the reason we say that is because um, the a log with the base and the content is going to equal the power, and root 2 squared is 2, which makes sense. The square of the square root is just going to be itself. So it's 2. And it's just a matter of integrating um, using this equation, which is the integral for polynomials, where in this case, n will equal 0 and k is 2. So if we just sub that in, we get this, not forgetting our bounds. Our bounds are very important. And then it's just a matter of carrying the calculation out, just like so. And then 2 pi over 6 is, of course, just pi over 3. And that simplifies to that, pi over 3. And there's your answer, so you can chuck a box around it. And there you go. I really do hope you enjoyed the video, and I look forward to seeing you guys next time.